Okay, this is Wednesday's math work. So we're going over pages 91 and 92, problems 4 through 8. This is number 4. So it looks like what they've done is they have broken apart some base 10 blocks for us so that we can look at the tens and the ones place in a multiplication problem and use that together to solve for 3 times 13. So let's first look at the tens, these like rods right here. We have 3 rows of 1 10 in each, which would be the problem 3 times 10, and we know that's equal to 30. Then we have this part over here, 3 rows, 1, 2, 3, with 3 single units in each row, which would be the multiplication 3 times 3, which we know because we've been practicing our basic facts that is equal to 9. So we can take those two partial products. We don't have the full product yet, and we can add those together. 30 plus 9 is equal to 39, and now we know the answer to 3 times 13. Example number 5. Did the multiplication equation here. It's written vertically, so don't let that fool you. First, they are wanting us to look at the ones. So they're saying that we have 2 rows, row 1 and row 2, with 5 ones in each row. So essentially, if you think about this vertical multiplication problem, this is the multiplication problem they're doing right here. They're starting in the ones place, because when we multiply and we do it like the old school way, or the standard algorithm way, the way that your parents and myself know, then we start here in the ones. So when we think about 2 times 5, 2 groups of 5, we know that is equal to 10. And now we're looking at the hundreds place. We have 2 rows of 100. So now we're looking at this part right here. And we know that 2 rows of 100 is the same as 2 times 100, which is 200. And if we add those two partial products together, we get a final product of 210. Moving right along. Turning the page, question number 6. What multiplication equation do the place value blocks show? So we have to come up with an equation that we see here. Then we have to find the product. Then we have to write a problem that could be solved using this model. So this is like a 3-step thing. We have to first do the equation, solve it, then come up with a separate problem. That's a lot of work. So let's take a look at the place value blocks that are illustrated. So I am seeing here separate rows. The equation almost looks like groups of 1, 2, 300. Then 2 tens is 20. Oops. And then 4 ones, 4. So if I put that together, that's the number 324. And how many of those groups do we have? 1, 2, and 3. So 324 times 3 is equal to blank. Now, what we could do, we could break this apart. We said 300 times, we're going to use the other factor, 3, 20 times 3, and 4 times 3. Then we'll add those partial products together. So we're using our basic facts of 3 times 3 is 9, but we multiply by 300, so we need 900. And then 3 times 2, which is 6, but we multiply by 20, so we need 60. And then finally, 4 times 3, which is 12. If you add those numbers together, you should get a final product of 972. So there's the write an equation. Step 2, find the product. Now step 3, to write a problem. What about, let's see. Okay, so I think about going to, because you guys are watching this and I know that I had to travel up to Moffat for a surgery. So I'm thinking about the parking garage because trying to park there is always fun. There are 324 parking spaces. We'll say parking spots on each floor in a garage. If there are 3 levels, meaning 3 floors, how many spots in all? How many parking spots are there? So that could be a sample problem. Multiplying 324 times 3. Let's look at question number 7. How many marbles are in 3 large bags and 4 small bags? So you could do this multiple ways. You could do, 3 of these and 4 of these. My brain automatically jumps to either multiplication of 80 times 3. Your brain might say, I'll just add 80 3 times. Either way, multiplication is just repeated addition, but you can use that basic fact of 8 times 3, which is 24, and then bring down the 0, so 240, and that's large marbles. I'm trying to point to that bag. That was a messy arrow. And then we need to solve for the small marbles, so 15, times 4. So that's kind of tricky. You could add 15 and do it 4 times. Or, if you don't want to do all of that, you could add 15 plus 15. And many of you know that in your head that it's 30. And then just double it because you did 15 times 4. So 30 times 2 is 60. Again, if you would have just added these, you would have gotten the same. 5, 10, 15, 20. 2, 3, 4, 5, 6, 60 matches our answer. So how many marbles? Let's see. In all, we need to add 240 plus 60. I know 40 plus 60 makes another 100. That would be 300 marbles in all. Last one, number 8. How can the distributive property be used to find 4 times 875? Draw an array. I am not going to require you to draw an array for that. That would take way too long. So let's do here 4 times 875. So let's first break apart this number into its place values of 800 plus 70 plus 5. It's kind of what we did up here with this problem. I can multiply each of these by 4. 5 times 4, that's your basic fact, right? That's 20. 7 times 4, hopefully you've been practicing your multiplication facts. 7 times 4 is 28, but you actually multiply by 70, so don't forget to bring your 0 down. And now 800 times 4, 4 times 8 is 32. And you have to add on these zeros because you have 800, so you'd have 3,200, also known as 3,200. Then you're going to add those numbers together. 3,200 plus 280 plus 20. Zeros all the way down. 8 plus 2 makes an even 10. 2, 4, 5. 3, bring it down. 3,500. Excellent. Great job today. If you need to rewatch any part of this video, feel free. Now you're going to complete the exit ticket.